Welcome back, everybody, to polynomial factoring. The next section that we're going to work on is factoring by grouping. And this method is part of the method that we've used for factoring quadratics. For example, let's say we had z squared plus z minus 20. So we said, what factors of negative 20 add to positive 1z? And that would have been negative 4 and positive 5. So then we brought down, we had z squared minus 4z plus 5z minus 20, and we split it in half. So in factoring by grouping, they're starting at this point right here, where they already have the 4 terms. And now we're going to go ahead and start straight at splitting it in half. So we split it in half, and our common factor on the left is z squared. When I pull out the z squared, remember, pull out means we're dividing, we're left with z plus 5. On the right side, we start with the subtraction. And the common factor between 4z and 20 is 4. So now we're dividing on the right side by negative 4. Negative 4z divided by negative 4 is positive z. Negative 20 divided by negative 4 is positive 5. And so at this point is where we would say, how do we know that we've done our factoring correctly so far? It's because these parentheses match. So z plus 5 is one of our answers. And then we pulled out z squared minus 4, which is the other part. But wait, there's more. This extra special factoring by grouping offer says I have more factoring that I can do. Z plus 5 is finished. There's no square still there. I don't have a trinomial. I don't have any common factors. So we're pretty confident we're done with the z plus 5. Z squared minus 4, though, that's a difference of perfect squares. Z squared is a perfect square. 4 is a perfect square. And we have subtraction. And so for this method, remember, we're taking the square root of both. Don't include that minus sign. And the square root of z squared is z. The square root of 4 is 2. One's plus, one's minus. Now this is finished. Example B. Again, we already have 4 terms, so we're splitting it in half. The common factor on the left is y squared. 3y cubed divided by y squared is 3y. Y squared divided by y squared is positive 1. We start with adding over on the right, and our common factor of 9y and 3 is 3. 9y divided by 3 is 3y. 3 divided by 3 is positive 1. So again, we're looking up, yep, there's my parentheses being the same. They're like terms. So we know we have factored correctly, and 3y plus 1 is one of our answers. We pulled out y squared plus 3. We need to check to see if this is an extra special factoring by grouping offer. And is there any other factoring that we can do? Well, no, 3y plus 1 is good. There's no more squares, no trinomial, no common factor. And then I look at y squared plus 3. And I say, well, I see y squared, but 3 is not a perfect square, and it's not subtraction. So I really don't see any other factoring we can do there, and that is where we stop. Example C. Again, we already have our 4 terms, so we're splitting this in half. The greatest common factor on the left side is x squared. That leaves us with x plus 2. We start the next section with subtraction, and the greatest common factor with 9x and 18 is 9. Now remember, we're dividing by negative 9. So negative 9x divided by negative 9 is positive x. Positive 18 divided by negative 9 is negative 2. So we check our parentheses here, and we run into a problem because I have an x plus 2 and an x minus 2. Because these are not exactly the same, this is not factorable any further. The last factoring form we'll talk about in quadratics is factoring in quadratic form. All of these are going to factor the same that we factored in chapter 3 with our quadratics. It's just that we have exponents that are larger than x squared. So when I look at example A, 16x to the 4th minus 81. If I go back and said, well, if this were 16x squared minus 81, I know 16 is a perfect square, x squared is a perfect square, 81 is a perfect square. This is subtraction. So I think that I'm going to use difference of squares formula. And so that's what we do, but we also use that x to the 4th. So the square root of 16 is 4. The square root of x to the 4th. Okay, we're taking half of that 4th power, which is x squared. And then the square root of 81 is 9. One's plus, one's minus. But wait, there's more. I have 4x squared minus 9. Well, 4 is a perfect square, x squared is a perfect square, 9 is a perfect square, and over here on the left, we have subtraction. So this is another difference of squares formula. So I'm going to set this up. The square root of 4 is 2. The square root of x squared is x. The square root of 9 is 3. One's plus, one's minus. And then I look at the right set of parentheses and say, oh, well, that adding there says that one can't go any further. And so this whole thing is my answer. Letter B. I'm going to start with, do we have a greatest common factor? And we do. Our greatest common factor is 3p squared. So I'm going to pull out or divide everything by 3p squared. That leaves us with p to the 6th plus 5p to the 3rd plus 6. Now I'm going to ignore for a minute the fact that it's p to the 6th in there, and I see 1, 2, 3 terms. So I'm going to try 1 times 6 is 6. The factors of positive 6 that add to positive 5 are going to be 2 and 3. Okay, remember when we pull out a common factor, we kind of ignore that until the very end, and we drop down, we have p to the 6th plus. Now remember, the 2 and the 3 have to add up to 5p cubed. So p to the third is what's going to go with that 2 plus 3p to the third. And then we again drop down that last 6. And this is where we have our 4 terms. So we are factoring by grouping. The greatest common factor on the left side with p to the 6 plus 2p to the third is p to the third. That leaves us with p to the third plus 2. On the right side, we start with that plus sign. Our greatest common factor with 3p to the third and 6 is 3. 3p to the third divided by 3 is p to the third, and 6 divided by 3 is 2. So we are again checking, oh, yep, inside my parentheses is exactly the same. So that's one of my answers. We pulled out p cubed plus 3. So that's another of my answers. I also need to come back and bring in that 3p cubed, or squared, sorry, that we took out from the beginning. But wait, I see p to the third power, and I know we learned formulas called sum or difference of cubes. So p to the third is a cube, so we need to check, is 2 a perfect cube? No, I don't have anything exactly identical 3 times that can multiply to 2, so that's good. What about p cubed plus 3? Is 3 a perfect cube? No, again, that's a prime number. So this is as simple as this one will get. All right, example C. So I'm again going to look and say, do we have a greatest common factor that we can pull out? And we do. It's going to be 2x to the 5th. We pull that out, we're left with x to the 8th plus 5x to the 4th plus 4. So we have 1 times 4 is 4. The factors of positive 4 that add to positive 5 are going to be 4 and 1. So remember, we're ignoring the 2x to the 5th that we pulled out, and we're starting with that x to the 8th plus 4. This middle term here is x to the 4th. So 4x to the 4th plus 1x to the 4th plus 4 from the end there. And then we're splitting this in half. Our greatest common factor on this left side is x to the 4th. So we have x to the 4th times x to the 8th divided by x to the 4th is x to the 4th plus 4x to the 4th divided by x to the 4th is 4. My next part starts with adding. And my common factor for 1x to the 4th and 4 is 1. Remember, you always have to pull out a common factor when you're doing factoring by grouping. Always. And so that doesn't change anything over there on the right. That's still x to the 4th plus 4. So we have nice. Our parentheses are the same. So x to the 4th plus 4 is one of our answers. We pulled out x to the 4th plus 1 for another answer, and we go back to our greatest common factor, 2x to the 5th. But wait, is there more? Well, let's see. This is perfect square, but it's adding. So I can't do anything with that. And x to the 4th plus 1, perfect square. But again, it's adding. So there's nothing more I can do with that one. This is where our notes will stop today. I'd like for you to remember to ask me tomorrow about this answer that we just did if we change the problem slightly. And we'll talk about that tomorrow. Have a great night.